Hi friends, we are going to learn in this session called performance analysis for the given algorithms. In previous sessions we have learned algorithm basic concepts, how to write the algorithms, order of growth, and part of order of growth we are going to discuss here as well, that how to compute time complexity, what are the parameters to be considered while going to perform performance analysis. Remember, we are going to discuss two important points, space complexity and time complexity. Out of that, as I mentioned earlier also, time complexity is very important for any given program. So, while you are doing the performance analysis, keep it in your mind that your algorithm will take lesser amount of space, algorithm will take lesser amount of time to execute the programs, algorithm must be free from, that program must be free from logical error, and program is working as per the problem statements. What are our expectations are there, a type of output we are looking for, we are getting it as accordingly. And last point, algorithm must have enough documentations to understand. So these all are the parameters of performance measurement, performance analysis. Apart from this, we have different method to compute time complexity for the given algorithms. So we are going to discuss in details, right, how to find time efficiency, time complexity, or you can say running time for the given algorithms. And we are going to discuss about clock function as well, how it will help you to find the time complexity for the given programs, any given programs. Look, while we are talking about the time complexity, measuring running time, we are having focus on to find basic operations. Basic operation, it means that our operations or instructions is going to repeat again and again, right, and perform certain task. Say as for example, since we have already learned in the first year, right, bubble sort. So in bubble sort, what is the basic operation? Is comparisons. We are comparing it, one element with other element. Similarly, when you have performed the task for matrix multiplications, what is basic operations? Is multiplications. We have learned already sequential search, right? What is basic operation in that? Comparisons. Key element with the given array elements is a basic operations. When we perform matrix addition or subtraction, what is basic operations in that? Is addition of two values of the given matrix A and matrix B. So addition is here called basic operation. In subtraction of two matrix, subtraction is a basic operations. So we need to identify first the basic operations. Say largest of the given list of element, maximum element of the given list of element. Well, we are going to perform the task. Again, comparison is a basic operation. So first you are going to identify basic operation. That basic operation is going to execute again and again until your all the loop based on that required loop is over. And when you are going to compute the time complexity, it is basically COP, basic operations, and it is going to execute how many number of times, right? So COP is running time of single operations, that is called basic operations. That operation is repeating how many number of times. If you are going to multiply those factor, it's going to give you time complexity. And we are going to learn with example called step count. It will be easier to understand as a beginner, right? Let us see. Here we have algorithm sum of array elements, some names we are given, sum of number of arrays, And since it is array, we have array index from 0 to n minus 1. If you have array index start from 1, you can go for 1 to n. Here we have input array of n elements, output is sum of n numbers, and we are going to compute how you are going to find out the time complexity. I is 0 for initializations, sum is 0 for another initializations for sum. This is the conditions. While I is less than n, we are going to add sum is equal to sum plus a of I in order to sum all the elements of array. And finally, I is equal to I plus 1 is a index we are going to increase, and return sum is going to give you the final values. So how exactly it is? Say here we have one array elements. We have a 5, 3, 7, 2, and say it is 4. Array index, since number of element is how many number of elements? 5. So array elements is 0, 1, 2, 3, 4. Now, initially I is 0, we are pointing over here. Sum is 0, sum is nothing. Whether I is lesser than n is 5. 0 is lesser than 5. Yes, it is true. Then what you are going to do? Sum is equal to sum plus a of I. Remember that this two statement is under this while loop, and this sum is equal to sum plus a of I is here basic operations. So you are going to perform the task. Sum is equal to sum, initial sum was 0 plus a of I. A of I, this is the array elements A of I, A of 0 is 5. So 5, we are getting 5. Now I is equal to I plus 1. I was 0, now I becomes 1. Is 1 is less than 5? Yes. Then you are going to write sum is equal to sum plus, look here, sum plus, so sum is, new sum is 5 plus a of I, a of 1 is 3 is equal to 8. Now new sum is 8. Similarly, I is equal to I plus 1, I increases. Now again you are going to check 2 is less than 5. Yes. Then we are going to do sum is equal to sum plus, sum is 8, right, plus 7 is 15. Right. Again I is equal to I plus 1. So I pointer is increases. Now it is 3. Is 3 is less than 5? Yes. Then you are going to do sum is equal to sum plus 15 plus a of I, a of 3 is 2. So 2 is 17. Similarly, I is increases, I becomes 4. So you are going to write 4 is less than 5. Yes. Then you are going to do sum is equal to sum plus, what is sum values? 17 plus, what is a of 4? Is 4 is 21. I increases, I becomes 5. Is 5 is less than 5? No. So it's terminated, return sum. And what is the value of sum, friend? Is 21. So this algorithm is giving you sum of n numbers, right? Now, what I said, basic operations or single operations you are going to repeat again and again. So basically this sum is equal to sum plus a of I, we are going to repeat again and again. How many number of times? How many number of times I have done it? Look, 1, 2, 3, 4, 5 times. 5 times. Since n is equal to 5, we have done 5 times. If n is 100, 100 times. N is 1000, 1000 times. So that is why time complexity for this algorithm is, when you are talking about the time complexity, it is n time, and n is one of the basic efficiency class, that is linear. I have already discussed in previous session that basic efficiency class and order of growth. So n is a linear complexity. So you can say that time complexity of this algorithm is, theta of n. Right? What we did basically, we are going to check this operation is repeating how many number of times. That is what it is going to give you the time complexity. Time complexity of an algorithm is the amount of computer time it needs to run the completions. Remember that this is not only depends on program. This is depends on input size. This depends on your software. This depends on also your hardware, right? And this also, of course, it is depends on a program, so what you have written it. Okay. quantity of output. Okay. So time complexity not only depends on your algorithms or programs, it is also depends on input size, software, hardware, and output. Remember, if we are having programs called finding prime number, whether given number is prime or not, same programs if you are going to run in 3 different machines, we are going to get 3 different outcomes, right? Reason is it depends on software configurations as well as hardware configurations as well. It depends on number of input. It depends on type of output we are getting it, right? So if program is same, purpose is same, then output will be getting same. Input what you are giving, it is same, but still time complexity differs because of software and hardware components, right? Depends which hardware or which system or computer is faster, it will take lesser amount of time to perform, right? So you should not worry when you are executing the same programs, your friend is also executing the same programs, right, in different system and getting different time complexity. It is but obvious. You should not think of that, okay? Because we are going to compute the time complexity in the form of nanosecond, and it's impacted by different other parameters. Fine. So let us see that we are going to compute time complexity for matrix additions, and we are going to get theta of n square. Okay. If m is equal to n, it means what? If it is a square matrix, then you will be getting n square. Otherwise, you will be getting mn. So let us see that how to compute the time complexity for matrix additions or matrix subtractions by using a step count method or a step table method. Let us see that. So how are you going to write? As our main function is matrix addition, so you write matrix additions. How many different parameters will have? How many different parameters will have? Will be having, if it is 2-dimensional matrix, we have 2-dimensional array, we have a 2-dimensional another arrays, and we are going to perform the task called matrix additions. Remember, since you are going to add element by element, we have to run 2 for loop. Say it is, we are adding for I is equal to 1, I less than, yes, is equal to m, I plus plus. Similarly, we are going to write another for loop for j is equal to 1, j less than equal to n, because we are considered it is not a square matrix, number of row is not equal to number of columns, hence it is, we have in this matrix m number of rows and n number of columns. Inside this, we are going to write, if this 2 for loop is there, we are going to write what is called resultant addition of 2 matrix. So say here we have resultant matrix as a C of I j is equal to, we are going to write A of ij plus B of ij, A of ij plus B of ij, right? So what will happen? It will take the array elements of the first matrix. Remember that for addition of matrix, you should have same order of matrix A and same order of matrix B. If order of matrix is 2 cross 3, then order of matrix must be 2 cross 3 only, because number of row must be equal in both the matrix, number of columns must be equal in both the matrix. So that is the basic condition is required. Once you are done with that, then definitely C matrix you are going to get it as a final resultant matrix. So we can write after that return C matrix, and we are going to perform here a step count method. How are you going to perform? So we are going to calculate manually, right, what is the time complexity, how much time it's required to perform. So here we are going to write a step, basic steps. we are going to write frequency and we are going to compute here total values. So we are going to compute for each and every. So here it is open curly braces. So even it is 1, we are not going to find any total values. This for loop will repeat how many number of times? Look, 1 to m is m number of times. One more time you will go and check for the failure case, right? Because this condition will fail while I will not increase. So we are going to write the basic operations. This particular step is 1. How many number of times will you repeat? From 1 to m is true case, successful case, and 1 where I value becomes m plus 1, m plus 1 is not lesser than m, that time it will fail. So we are going to check the condition, how many number of times? M plus 1 time. So m plus 1 into 1 becomes m plus 1. Now for this for loop, how many times it's going to repeat? This for loop is going to repeat from 1 to n true case and 1 j is equal to 1 to n true case and j is equal to n plus 1 false case. So n plus 1 time. For every value of a, every value of I start from 1. For each and every value of I is equal to 1, j will start from 1 to n. I is equal to 2, j will start from 1 to n. I is equal to 3, j will start from 1 to n plus 1. So it will, each and every value of I, j will start from 1 to n plus 1 time. So let us see, this is a 1 instructions and how many number of times it is going to repeat? For true values of I. True values of I means what? How many number of times? M time. And it is going to repeat for each and every I is going to repeat for n plus 1 time. So if you are going to multiply this, it is going to be mn plus m. Similarly, this statement is basic operations. I said that basic operation will repeat again and again. So this operation is going to be the basic operations and going to perform the task for addition of two matrix. And how many number of times it is going to perform? True case of I, true case of j. So I is from 1 to m, j is from 1 to n. True case. So this is m time, this is n time. How many number of times? This particular operation is going to perform, instruction is going to perform m cross n time. So basically it is mn time, right? Yes, these are the return values. It is just one instructions. We are not going to repeat it. So just we are not considering this. Even we will consider it is 1. Now, and we are not worried about the constant part 1, 2, 3 or 100. We are really worried about order of growth. What you have discussed, the basic efficiency class. Those parameters, those basic efficiency class, we are going to focus. If you are going to find out the sum, what is the find out total complexity? Look, this is complexity, what you are getting, total values you are getting. Based on that particular instruction is repeating how many number of times. How many number of times. And now we are going to calculate compiler worked for how many number of times, iteration by iterations, right? So let us see that here mn, it is 2mn, m, it is 2m, and this is the constant values. Now, if this is mn, if I will say you that if m is equal to n, it means what? Order of matrix is a square matrix m cross m or n cross n. In that case, what will be the time complexity, friend? Time complexity will be theta of m square or n square when m is equal to n. If m is not equal to n like this, then time complexity is theta of m cross n. Remember that. Why remaining parameters were not considered here? You have written mn but not m and 2, because these values are lesser than mn. These values are lesser than mn. So just in front of larger values we have ignored it constant part or linear part, because here you are getting quadratic m cross n, right? So this is all about the time complexity by step count method. Time complexity by step count method. Now, to understand how to find time complexity for the given program, let us see. We have a program, we are writing the main functions and all. We have a program, say main. We have written here int I comma n, right? Say you are writing the programs for computing the factorial, right? Here you ask printf enter the number of elements. We are writing scanf, right, ampersand n, right? Then you are asking printf enter n elements one by one, right? So if n element means what, you have to use a for loop. So let us have for loop for I is equal to 1, I less than equal to n, and I plus plus, and we have used scanf percentage d double quote comma, and we have a name of array, say it is a of I. So we need to define here array's name also. So let us have int a of 10, right? Int a of 10, if you are talking about maximum of 10 elements. We have taken of n elements to perform the task, right? And now we can perform along with these n elements, whether you are going to find out the sum of n number of elements or largest of n elements, depends of our choice. Whether you are going to find out the factorial, then one number is enough to find the factorial, right? Or if you wanted to find the factorial of all the elements, then you have to write the program accordingly. Say in a simple way, I wanted to teach you that how to find that, what is called complexity of the programs. So let us see that we are going to find out the max element. Max element is a function. So here is a calling function, and here you are going to print max element is percentage d double quote comma, and say here we are having some values called max is equal to max element. So max. So we are going to write here max. So max is a variable, max element is a function we are going to use, and a is a array name. So max, you can print it, it will give you the maximum values. But before that, we need to use this function max element. If you are calling as a factorial, you need to use the factorial functions, or you can write the code over here only, right? So depends. If you are writing over here, both are the proper way of writing the programs. Either you are going to write the program by calling functions, or you can write the programs directly. So if you are writing the programs like this, then we are going to compute the time considered this part, how much time it will take. For that reason, if you are defining the max here, say here we have a int max element, here you can use that complete along with the parameter, int a, and say consider your max element is a of 0, or whatever the array we have defined it, a of 1. A of 1 is a max element. Now you need to write the loop for I is equal to 2, I less than equal to n, I plus plus, and you can say that if a of I is greater than max, then you are going to write max is equal to a of I, and finally you are going to return max. Okay, return max, or you can give any values here, I max, return I max, because we already use variables, right? So what will happen, this will give you the largest of these element, and it will come and sit over here. Max element is whatever the values are there, you say 5, 10, 15, 20, 25, 25 is the largest element, it will give you. But how to use that functions called time? Remember that for time functions you have to use hash include time dot h, and we need to define here clock underscore t start comma end. Remember, when you are going to find the time, some person will ask you how much time it will take from your home to college. Then time start at your home, that is start time. Reaching to college, that is called end time. So always you are going to do end time minus start time. So same things you are going to perform here in any programs. So how we are going to perform before calling these functions, max function, because we are calculating the time complexity for max element, not for other main functions and all. So in that case we are going to call here start is equal to clock. Start is equal to clock. So clock is a function, it will be calculating the start time and stored in start. Once it is done with that, we are writing here end is equal to clock. Clock is a function, C-L-O-C-K, clock is a function. So we are going to write start is equal to clock, end is equal to clock. Now when you are writing C functions, then we have a functions called, when you are going to calculate duration of time durations, then we can do it end time minus start time, right? End minus start. So these values end minus start is having unit called tick, clock tick, clock tick. So in our real life, we are knowing the time unit is second, minutes and hour. So this is our duty, is to convert this clock tick minus clock tick is clock tick. So clock tick into the clock tick per second. So there is in a C function called CLK uppercase TCK, that will convert these time into the second. So unit of this is clock tick, unit of this is clock tick, and when we are talking about clock tick in uppercase CLK underscore TCK, unit of this is clock tick per second. So what will happen? Clock tick divided by clock tick per second, overall time of this we are going to get it into the second. So this is the first function to find out the time complexity. Second is, if anyone is writing the programs in Java, then even in C that function will work. So what is that? Time duration is, we are going to write time duration is equal to n minus start divided by CLOCKS, clocks, PER per underscore SEC, clocks per second. Again, this function will allow you to perform the task and finding the time complexity in the form of clock tick per second. So final time will be well known time unit in the form of second. And if you are going to create the delay, if you are going to increase the delay, then time complexity will be given in the form of microsecond, millisecond, that we can convert, depends on our knowledge and requirement. We can convert time unit in the form of required time. Conclusion is, for any programs, this is our duty, is to perform the task such a way that or write the program such a way that it will be more effective and consume lesser amount of time. So let us see example. When you are finding the given number is prime or not, there are three different methods. One, say we are going to say use one for loop and finding that whether the given number is prime or not. As you know that finding prime number is what? If number is divisible by itself and 1 is only called prime, right? And both should be the different parameters. So in that case, if we have values n and we are going to find out a given number is prime or not. So we are writing the for loop to divide from I is equal to 2, I less than n, I plus plus, right? And you are going to write one for loop, if condition, if num mod 2 is equal to num mod I, num mod I, num mod I is equal to 0. In that case, it is not a prime. So we can say here flag is 0. So initially we are going to define flag as 1. It is for true or false case, right? So this will repeat again and again. At last, still it is, if flag is 1, a given number is, you are going to say it as a printf, it is a prime. As printf not prime. Similarly, there is another programmer in front of you or maybe sitting with you in the class is going to write the different program. How? Different program means logic will be different. Say here they are going to use for I is equal to 2, I less than equal to n by 2, I plus plus. So at the place of n, we are going till halfway, because if number is divisible by 2, no need of checking with the after halfway mark. I will tell you with the example. If num mod I is equal to 0, so flag is 0, here flag is 1. In that case, again, remaining all statements you are going to write as it is. Third case is, we can write even more effective and will take lesser time. I is equal to 2, I less than equal to sqrt of n. I less than sqrt of n. What is sqrt function? Find square root. And then you are going to write these all statement if num mod I is equal to 0, flag 0. Right? And remaining all statements as it is. What will happen, friend? If you are going and finding where n is equal to 101 is a prime or not. So in this case, it will go from 2 to 101. 2 to 101 means 100 times you are going to execute this. Okay? While here, so this is what? 2 to 101 is 100 times you are going to perform. In this case, it is going to perform from 2 to 101 divided by 2 is 50. So it is going to perform 49 times. While in this, it is going to perform 2 to a square root of 101. So maybe it is 10 point something, right? 10 point something. So 2 to 10, it is 9 times. So look, we have 3 different algorithms for finding whether given number is prime or not. One is compiler used to take 100 times and then conclude that given number is prime. While in second case 49 times, third case only 9 times. Then being a programmer, we can easily judge which algorithm is faster or efficient in compared to all 3. Of course, third case is more effective, taking lesser amount of time to perform the task. So likewise, you have to think when you are going to perform the task, to find, or to measure performance analysis. We have discussed in this particular class performance analysis, how to compute the time complexity by using a step count method, and then we have taken some examples to compare which algorithm is considered to be the best one based on the performance analysis, and we have learned time function as well, how to find the time complexity. Thank you very much.